So the help that I will give you for problems 14 and 15 on the test review sheet to get you ready for this. It's primarily a Chapter 7 test, but we're going to review some of our previous topics just to help us with the semester exam that's coming up. So this is called a composite function. Really should have an extra parenthesis there. So the way you deal with these is think inside out. All right, so I'm going to start by evaluating f of -3. That's on the inside, and that means I'm going to input -3 in place of x in this f function. So we're doing inputs and outputs. So if I input -3, -3 squared is 9, and 9 plus 5 is 14. So the way a composite function works is once you find out what the inside is, so just think of all of this being 14, now you're going to evaluate g of 14. So find out what the inside output is, and then use that as an input into this other function. So g of 14 is going to be 2 times 14 minus 3, and 2 times 14 is 28 minus 3. So our final answer, it's not two answers, it's just one final answer for number 14, is 25. All right, number 15, same thing. I'm going to evaluate first g of 2. What is the output if I input 2 in place of x? All right, 4 minus 3 is 1. So now that output is going to be used as an input in the f function. So I put 1 in place of x. 1 squared is 1. 1 plus 5 is 6. So there's your two answers for those two composite function examples on this review sheet. And then I'm also interested in you remembering, because you're going to do this on your exam, I want you to remember how to solve these log equations, and it's also going to require that you remember the log properties. We have the product property, the quotient property, and the power property. That's really the purpose for these two problems. Do you remember those properties, at least most of them? And then do you know how to use them to help you solve for A in number 16, and then for Y in number 17. So the rule of thumb is when you're dealing with a log equation and you notice that there are two separate logs on one side of an equation, that's what we have here in number 16, two separate log base 3s. Our first job is to make those become just one log base 3. And since they're being added, this is going to be an application of the product property. Not that you have to write that on your test, but I just want you to know that's the reason for this problem. Do you understand how the product property works? And it basically says two separate logs that were being added together can be joined together as one log using multiplication. Okay, so if I multiply 3 times a squared plus 3, I would get 3a squared plus 27. All right, so I've done the first thing that is required. I've made two different logs become one single log using the product property. And now log equations, just think of this, log equations have to always be changed into exponential equations. All right, so let's just do a quick example before I come back to my problem. Here's a log equation. Log base 2 of 8 is 3. Okay, real simple. Here is the exponential form of that. 2 raised to the third power is equal to 8. Okay, so that's how we go from log to exponential. Notice in exponential form, we get rid of the word log and we just write the truth that 2 raised to the third, 2 is the base. Remember, logarithms are exponents. So 2 raised to the exponent 3 is equal to 8. All right, so now let's come over and jump back to our problem. If I change this log equation into an exponential equation, it's going to look like this. I take a base of 3, okay, look like we did here, base of 2. I let 2 be raised to the exponent 3 because that's what the log equals. Do the same thing here. 3 is going to be raised to the 3rd power. And I just noticed I did a really dumb thing, so I apologize. 3 times 3 is not 27. I was thinking 3 to the 3rd. So sorry about that. So anyway, I don't want to do this video again, so hopefully you were probably wondering where in the world did he get 27. So yeah, you're right. I lost my mind there for a second. Okay, so we're back. So I'm changing log to exponential. So I take a base of 3. I let it be raised to exponent 3, just following this model. 2 raised to the 3rd equals 8. 3 raised to the 3rd equals 3a squared plus 9. All right, and now you solve it just like you would a regular equation. 3 to the 3rd is 27. And I'm going to solve for a by subtracting 9 from both sides. I will now undo division or multiplication with division. 18 divided by 3 is 6. And now I'll do the square root of both sides. I'll just come over here and finish this. Let's just go over to the right a little bit. So when I do the square root of both sides of an equation, I have to include plus minus. We talked about that a lot because I'm supposed to come up with 2 answers. And if I just do the square root of 6, I've come up with only 1 answer. So my final answer is just plus and minus, positive root 6 and minus root 6. And if you come up on a radical on your test, you can leave it just like this in simplified radical form. You don't need to give me the decimal equivalent of that. All right, so there's your answer for number 16. Now number 17, the same idea. 2 logs have to be turned into 1, but notice instead of addition, we have subtraction of 2 logs. So this is going to utilize our knowledge of the quotient property. So 2 different logs that are being subtracted. Now, as long as they have the same base, but all of ours do, but those properties always imply that you're dealing with the same base with the 2 logs. They don't work if the bases are different. So the quotient property says 2 logs being subtracted will be joined together as 1 log using division. All right, so I've taken 2 and I made it 1. And now we're going to go back to what we talked about over here, our little discussion about log to exponential. The base of the log raised to the number that the log is equal to, that's the exponent, and that's going to equal this expression 2y plus 2 over y minus 2. And now to solve for y, since we've done a lot of this with solving rational equations, I'm going to multiply by the lowest common denominator, which is y minus 2. So when I do that, it cancels these. The right side's pretty easy. Left side, I just have to distribute 4 to both of those. And now I just solve for y like we've been trained to do. We've done a lot of these. I'm going to subtract 2y from both sides. I'm going to add 8 to both sides and then divide both sides by 2. And there we have it. All right, so those are your 2 answers for the 2 log problems. You'll see 2 log problems on your test, very similar to those. So I want you to be ready. You'll also see some log problems on your semester exam. So trying to kill 2 birds with 1 stone with this test. Get an early start on our semester exam prep. The margin of error formula, just want to review that with you because it's going to come up again, is 1 over plus minus, it's plus minus 1 over the square root of n, and n represents the sample size. All right, so pretty easy, just need your calculator. Our margin of error, but don't forget the plus minus because it's going to build a range around the sample proportion, which you don't have to find in this case, but knowing that the margin of error is a plus minus number is important. All right, so plus minus 1 divided by the square root of 3,400. All right, so you'll probably want your calculator for this. So I went to my calculator and I got, it shows in my calculator 0.017149 and we're just going to change this to percent form. So you could, if you want to, with that number still in your calculator, you can multiply it times 100 to change it to its percent form. Or if you want, you can just slide the decimal 2 places to the right, and that's another way of multiplying by 100. So we'll just leave this rounded to the nearest tenth. So our final answer here is going to be plus minus 1.7%. All right, another thing I want to review with you, looking ahead to the semester exam, is this idea of the normal distribution. So let's just do our standard normal curve. So for a standard normal curve, and we're told that this represents a normal distribution, so we can go ahead and pull out the standard normal curve and remember that this is the mean, and we're told the mean average is 31. And the standard deviation is 6, so we'll add 6 going to the right, and we'll subtract 6 going to the left. And within 1 plus minus 1 standard deviations of the mean, this represents a total of 68% of our data, 34 on each side. And then when we go out to 2 standard deviations, this is 13.5%. And then finally, catching all of the data, this is the rest of it, 2.5% on either side. All right, so that's the curve, and we want to know how many runners. Okay, so on the last test, our statistics test, some of you gave me a percentage of the runners, but this wants to know how many of the 800 runners were between 37 and 49. Okay, so here's 37. Here's 49. Well, that represents 16% of the runners. Well, now to get the number of runners, we have to do that calculation. 800 times 16% as a decimal. And when we multiply those together, we'll have our answer. 800 times 0.16. And we got 128 runners are within that age range of 37 to 49. All right, that takes care of number 19. Make sure you understand the standard normal curve, normal distribution problems. And then finally, a little right triangle trig review. We're going to use either sine, cosine, or tangent to solve for x. All right, so this is an angle. And for that angle, I'm given the opposite side of the angle, and I'm also given the adjacent side of that angle. And that just happens to describe tangent. Tangent is opposite over adjacent. So tangent for some angle that we don't know yet, but we will know soon, we're calling it x, is the opposite side of the angle divided by the adjacent side. So anytime you're trying to find an angle measurement, you always have to use what we call inverse trig. And that little second -1 in your calculator, tan with a looks like a -1 exponent, that is, it's either second tan or it's inverse tan. It's also later on you might see it referred to as arc tan. But whatever, you're going to have to go to your calculator and do the second button, then tangent. And that's going to be true anytime you're looking for an angle. All right, so it's pretty easy now to go to our calculator and do second tangent. and then 9 divided by 12 in the parentheses. And we'll just round these to the nearest tenth. You can do the same thing on your test. So that would be 36.9 degrees is angle X. All right, on number 21, we're looking for a side measurement. So we do not use second sine, cosine, or tangent when we're looking for sides. Let's pick the correct trig function for 43 degrees, see what we're given. We are given its adjacent side, and we're also given the hypotenuse. Remember, the hypotenuse is always across from the right angle. So that happens to describe the cosine ratio. Cosine is adjacent over hypotenuse. So that's the trig function we're going to need to solve this problem. So cosine for the angle 43 degrees is the adjacent side, which we are given, divided by the hypotenuse, which we're trying to find. So mathematically, what's going to happen is we're going to multiply both sides by x, because that's the lowest common denominator. And we end up with this equation because those x's are going to cancel. And now I have to undo multiplication with division. So the way I get x by itself is I divide by cosine 43 on both sides. And now you're ready to turn to your calculator, and you're going to do 31 divided by cosine, and then in the parentheses 43. And again, to the nearest tenth, that would be 42.4. And that is the length of the hypotenuse for this right triangle. Okay, that wraps it up. You have another separate video that will cover the first 13 problems, and then I wanted to do this one to help you with the remaining problems. So I hope the two together will help you get prepared, but if not, you still need help, please know that you can always reach out to me. I'll be glad to help you. Either send me an email, come and visit, see me before school, and otherwise I will see you the next time we meet.